In this lesson, we'll learn how to analyze the interaction between solid components. After completing this lesson, you'll be able to activate contact sets. After we've created our joints and added joint limits, the next thing that we want to talk about is contact sets. This is where Fusion is looking at solid interference between bodies or components. Now remember, bodies cannot have joints applied, but they are still a physical volume inside of the environment. They are stationary, but other components can move around and potentially interact with them. So let's take a look at the Assemble dropdown and select Enable Contact Sets. From here, we're going to right-click and we're going to create a new contact set between the camera and the red servo. Let's go ahead and say OK. And notice that it cannot be resolved due to joint conflicts. So this is telling me that there's a joint in place that is causing an issue here. Now I'm going to take Revolute 5 and I'm going to temporarily suppress it and try to move the camera. And it's still telling me that there's a warning that the positions cannot be accounted for because of this issue with the joint. So let's go ahead and edit the joint limits. And we're actually going to turn the joint limits off and say OK. And try to move the camera again. And notice that it's not moving. We no longer have the caution telling us that it can't actually evaluate it because of the joint, but it's still not able to move. Now if we rotate this around and we take a look at this, we actually have a small amount of overlap between the servo and the camera itself. Now we can go up to Inspect and we can take a look at interference between components and we can find that, but this case is actually fairly easy to find anyways. If we come up to interference, notice that some components have been moved. If we continue, it'll revert back to its original position, or we can capture position where they currently are. So we want to look at interference between these two. We can include coincident faces, and we're going to go ahead and compute. And notice that it did find some overlap, and it's all in this area right here. We're going to say OK, and we want to modify this. So we're going to modify, we're going to press pull this face, and we're going to pull it back and say OK. Now you can see that we have a little bit of a gap there. Now if we go to the front view, we can now move it up and down until the camera interacts with this point on the servo. So this is telling us that this is our limit. That's as far as we can move this camera until we interact with solid geometry. Now let's say that we come back to this servo and we're going to apply a fillet to this corner here. Let's give it a 3mm fillet and we'll say OK. Go back to this front view. Now again, we're contacting that solid corner on the bottom, but as we rotate up, the fillet now gives us enough clearance to move past it. So now we can go all the way up. And in this case, it's not calculating the intersection between this solid body up top, so we're able to just simply move through it. But we can only go down into that corner on the bottom, and then it's going to physically stop it. So this is exactly what contact sets are good for. When you have a physical limitation in the motion of parts, whether they're electromechanical or simply purely mechanical parts, that physical limitation either if it's intentional, if you have a physical stop that you want to make sure it's in the right location, or if it's unintentional, such as this camera and servo, making sure that we have enough clearance so that the camera can actually tilt up and down. These are the types of things that the contact sets are really good for. I will caution you to using the contact sets enable all contacts. It'll look at all solid bodies and it'll try to calculate that. If you have any joints with joint limits, such as we did here, where a revolute had plus or minus 45 degrees, it will not allow you to calculate that because those joint limits would override some of the contacts. And also if you have interference, that'll just completely lock up the joint as well. So it's a good way to test a few things, such as your interference, but if you're taking a look at components that actually have a press fit or a tight fit or an interference fit, maybe they're sliding against each other and they're spring loaded. These could potentially lock up in the Fusion environment just based on how they're modeled. If there's a slight overlap in components, but in reality they're actually squished together, that could limit the motion here. But in general, I like to use contact sets anytime I have a physical stop, or if I'm trying to build or design an assembly and I want to figure out the physical limitation. So that's another great option for me to use on here. Now in our case, we don't really need to worry too much about the physical limitation because the servo and the mounting position for the camera have already come in from Fatshark. They're designed to work together, and this piece right here was reverse engineered from a piece that came with that assembly. So the location of the holes, where they bolt onto the servo, and the pivot point for the camera, again, also came directly from those components. So the image and the CAD file that we have on the screen is just a loose representation to make sure that we understand the geometry that we're using. So I want to go ahead and I want to disable the contact sets, and I'm going to go ahead and disable all contact sets. So I want to go back into Revolute 4 and I want to edit the joint limits. Notice that when I click minimum and maximum, that they come back up 45 plus 45 minus 45. Now these are actually a bit too much. In the minus direction, let's see, we're going to go plus 20 degrees, and the minus direction minus 65, and we're going to say OK. Now remember, we're not going to be using this green servo. We don't need to pan, so it's going to be removed. It's only simply there so we can explore the joints. So now we can move it up and down, and because I didn't put that rest position in, it no longer snaps itself back to horizontal. So we're going to revert the position and we're going to save our file.